Data governance is becoming an increasingly relevant policy question. Data privacy, data sovereignty, and data exchange between countries are all large issues that must be addressed in order for insights to be mined from and synthesized across data of all kinds. Data is so important that a few years ago, The Economist declared that it was worth more than oil. As major a claim as that is, it's a pretty faulty comparison. Unlike oil, data can't be used up. It can be endlessly stored, amended, and created, meaning that its value can fluctuate wildly over time. In other words, we simply can't assign an economic value to data in the same way as something like oil. But it's very important that we give it some kind of meaningful value. We all know from the Faustian bargain we've made with social media companies that they've gotten rich from our personal data. Is that really fair to us? If our data is worth so much, shouldn't we get a cut of the action? But that's just the tip of the iceberg. Data can be life-saving in disaster mapping or drug discovery, and it's the engine of economic growth in fields like product development and urban planning. One way or another, data touches nearly everything we do, and we need to have a good sense of exactly how much we should be paying to gather, store, and analyze it. Therefore, I am proposing here a broad methodology that can be used to economically evaluate any given dataset in the context it's being used. Data is valuable because we can use it to determine how likely something is to happen and make decisions accordingly. This leads us to the expected monetary value, or the payoff of a decision multiplied by the likelihood of relevant events. You can look at the decision tree on this slide as an example. Depending on which decision a dataset is being used for, it will have a different monetary value. Furthermore, we can consider the expected value given perfect information, which is how much it would be worth to know what particular outcome is going to happen with full and complete certainty. That's an ideal, of course. We can almost never know anything with certainty. But it does allow us to consider the expected value of perfect information, which is the difference between the two previous quantities. This tells us how much it could be worth to gather additional data to make us more certain about the decision. Using this framework, we can readily determine the value of both the data we have and the data we lack for any given decision. This is early research, so my next step is to operationalize this. How can I estimate the payoff of different kinds of decisions? How can I use the datasets to determine different likelihoods that could affect the expected monetary value of each decision? I expect that the answer will depend on the different kinds of datasets that are used in these kinds of decisions. Depending on the different statistical analyses available, ranging from ANOVA to p-values to machine learning, there are different options to assess probability.